Did you know that the word torque is derived from the Latin word torquere, which means to twist? Now that's a tidbit to twist your mind around. Torque, or the moment of force, is a fundamental concept in physics. It's the rotational counterpart of linear force. In simpler terms, it's the force that causes objects to spin or rotate. Just as a linear force triggers linear acceleration, torque induces what we call angular acceleration. Picture a seesaw. You're seated on one end, and with a push from your foot against the ground, you exert a force. But here's the twist. This force isn't responsible for the seesaw's up and down movement. Instead, it's creating a twisting motion around the seesaw's central pivot point. The strength of this twisting motion hinges on both the magnitude of your force and your foot's distance from the pivot point. And voila, that's torque in action. Now for those who enjoy a good formula, here's how we calculate torque. Tau equals F times D times sin theta, where tau is the torque. Measured in Newton meters, F is the force applied. Measured in newtons, D is the perpendicular distance between the line of action of the force and the axis of rotation measured in meters, and theta is the angle between the force and the lever arm measured in degrees. The key takeaways from this formula are: the stronger the force, the stronger the torque. The further the lever arm from the axis of rotation, the stronger the torque. The closer the angle to 90 degrees, the stronger the torque. Now let's see how torque plays out in our daily lives. When you open a door by turning the doorknob, you're applying a force that creates a torque, causing the door to rotate. The same principle applies when you turn a screw with a screwdriver, or when you pedal a bicycle, causing the chain and then the wheels to rotate. If you're driving a car, the force you apply to the steering wheel creates a torque that turns the front wheels. And when you use a wrench, the force you apply to the handle creates a torque that rotates the bolt. Torque is not just a concept that makes our daily tasks possible. It's also integral to various fields. Engineers consider torque when designing structures like bridges and buildings to ensure their stability. Robots rely on motors that generate torque to move their arms and legs. And in sports, athletes use torque to throw objects, swing bats, and perform other athletic maneuvers. So, by understanding torque, we not only comprehend the forces that make the world go round, quite literally, but we also gain a deeper appreciation for the forces that shape our everyday lives. Now, isn't that a twist worth knowing?